So let's get on to this class. It's Introduction to Biostatistics. Primarily, we are going to see on descriptive statistics. So we'll see what is descriptive statistics. This slide is courtesy of Dr. Sobia Pilal. All right. So what is the objectives of this lecture is to introduce what is statistics, a little on biostatistics, and appreciate the scope and use of statistics, to be familiar with terms used in statistics, and to understand the two main branches of statistics, as well as to understand what is descriptive statistics. Okay, so what is statistics? So in simple terms, you can say that it is to make sense of the data you collect, right? We collect a lot of data and we have to make a sense and a more accurate sense of that data. So that is helpful with the use of statistics, right? So status means manner of standing or position, and it tells where the data stands for us, right? So it's a science that deals with the collection, organizing, analysis, interpretation, presentation of the data, right? The information which we say is nothing but the data. So whatever you get data, right, you get a lot of data. For example, you want to check the age of a group of people, right? You will have individual age coming from each of us, but if you want to make a sense of it as a group, what is the group's identity based on age, then you might take an average of it, or you will put it as a graph and see how it spreads, how is the spread of it, how many persons are in the higher range or how many persons in the lower range. So all those things we use statistics to do it, right? We collect the data, we organize it, and we make sense of it, right? So why we should study statistics is because it is a tool for research and is also easier to communicate with a statistician once we know how what we want and what kind of presentation we want and what kind of things we want to get tested and all those things, then it is able to be communicated. So understanding dental literature also is another useful thing of studying statistics. So overall, to have an appreciation of statistics so that we can know when and for what purpose a statistician should be consulted in dental research. So let's get on to some basic terms. Okay, so what is meant by population? All right, population means that the thing of interest you are interested in studying. For example, it could be a population of patients on whom you are interested to study about endodontic problems. All right, so who the population would be? A population would be those persons who have endodontic problem. All right, so it won't be any other persons, but a person specifically with endodontic problem. Or if you are interested in studying about young people, right? For example, we are interested in studying about persons with the effect of dental caries on young people, right? So let's assume that the young people are from the 6 years to 10 years. So who are the population will be? All the kids who are under 6 to 10 years who could be our population, because that is the population of interest. We want to see how dental caries affects them, all right? So we will also need persons with dental caries. We also need persons without dental caries. All right. Then what is a sample? A sample is a part of a population. All right. We have to select a population so that the sample can say what the population has or what the population is. All right. Usually we go for a random sample. So our question is that a sample is a part of a population and we want to make sense of the whole population based on this sample. And then why do we want to take a random sample, right? This random sample is the right way to take a sample from the population so that it represents the population. So that is a question for you. The other terms are data. Data is nothing but information. So we have a sample, right, who have taken from it, because we cannot take the whole population. For example, if it is like we want to understand the effect of dental caries on kids 6 to 10 years, then in Malaysia, right, we cannot take all the kids of Malaysia. That would be the greatest study, right? It will be a very unbiased study, will be an accurate study, but it is not very feasible to take millions of kids coming into the study, right? So what we do is we take them, and from that small sample we take an information, right? So this information should be representative of the whole Malaysian population of kids, right? So the raw material of statistics is called data, which are numbers which contain valuable information. From this information only we have to make sense of the people we are going to target to study. And what are the sources of data? We can have kept records. For example, open dent has a lot of data, right? So we can use that data. You might have done this clinical audits and all those things. So we take data which is already stored. Sometimes it can be from surveys where we freshly collect data. We collect it as a first-hand experience. We ask them, right? If it is kept record, someone has recorded it for you and you're taking that records. But if it is surveys, it is almost a first-hand information from the directly from the participants. It can be from experiments. You first-hand see the data and collect it, or from external sources. For example, if it is going to be like a literature review and all those things, you collect other data and put it and do the analysis. And what do you mean by a variable? Variable is a data, right? A particular form of data. For example, I want to see the age of a person in the group, right? The age of every person will vary. It won't be the same, right? So the data which varies, right, is called as a variable, right? A characteristic, for example, age is a characteristic which varies among different people, then it is called as a variable. If there is no variation, then the characteristic is not a variable. For example, you have taken all the subjects from Malaysia, right? So that was your inclusion criteria, that whoever is Malaysians will be part of the study, right? That cannot be a variable, because if you take that data from everyone, they'll always say Malaysia, Malaysia, Malaysia. So it won't be a variable in that particular study. But in an international study, it can become a variable. The country can be a variable, right? So, yeah. So some basic terms which we can use is like hobby. Hobby can be characteristics. So every person can say something. Facebook, Instagram, or bird watching, all those things. Education can be master or a diploma. Car use, BMW or Viva. Cosmetic brand used, and bank account. Each people can have a different bank account. So these becomes a variable. So we use the data collection form to collect the variable in the form of data, right? ID, it can be assigned, or they can have their own IC ID, right? Age in years we can put it. Sex, you can assign female as 1 and male as 2, right? So this one has only a nominal rank for it, right? It doesn't mean that the males are second and the females are first, right? It just means that we have assigned a number 1 because it is easy to do manipulation with numbers. Occupation, having job, can be 1 and jobless can be 0, right? For example, a person's data, right, of the ID number 1 has an age of 25 years, is a female, and has no job. Like that, we have collected the data for 10 persons on age, sex, marital status, and occupation. Do you see that all these are varying among these 10 participants? Here also it's varying, here also varying. So all these are variables. Now coming to the two branches of statistics. One is descriptive and one is the inferential. So what is the descriptive statistics? It is the organization and summarization of the data and describing the data by summarizing them. It's just summarizing, right? It is just presenting the data as it is, right? We are not actually analyzing it and making meaning of the data, but we are using the various ways of proportion, percentage, mean or median, and making sense of it before analyzing it, right? It can be in the form of ratio, like A bar B, right? Ratio of boys to girls, right? So in that study you saw that 5 was boys and 5 was girls, so the ratio is 1 is to 1. And proportion, how many persons are boys over the total population, right? So in that we had 10 participants in the study you just saw. I'm talking about this study, right? We had 10 participants and we find that 50% are boys, right? So it is 5 out of 10, or 1 out of 2 proportion is males. Percentage is same, 50%. And rates is, sometimes we employ rates to describe the characteristics, right? One of the popular thing is the infant mortality rate. So infant mortality rate gives a clue of the health of the nation itself, or the health infrastructure of the nation, right? Infant mortality rate is given as number of kids who died from the total denominator of live births in 1000. Okay, so out of 1000 live births, how many kids died is the infant mortality rate. So if the number is high, like 10 or 12 or 20, it is like it is a high infant mortality rate. Developed nations will have around 2, 3 or 4 only. So that will tell it, I think. And this can be compared against countries. So sometimes we put it as rates also. So what is descriptive statistics for? In any study, before we answer the research question, we should introduce the characteristics of the subjects like age, gender, ethnicity, and other data. We have to present it to the person that this is the population I'm talking about. This is the sample I'm talking about. For example, in that thing, if you see the age, we can see that it is all in the range of 20 to 30 years. So you know that they are all young adults, right? So this is the reason we also use descriptive statistics to introduce what study data we have. The other branch of study is the inferential statistics, right? It is like to infer or to get meaning of what the data we have collected. So we use techniques by which inferences can be drawn and decisions can be made, right? And we also use sample statistics observed are inferred to the corresponding parameters, right? Now coming to the type of variables that also makes us understand how to present the data, also how to analyze the data, right? We have basically two types of variables. One is a qualitative variable, categorical variable, or quantitative numerical variable. Which all variable which can give information in categories, for example, boy and girl, right? We cannot numerically assign some number for them, right? We can assign them as a notional number only. For example, one can be boy or one can be girl, any number they can take, right? So they will be called as categories, right? Or also education, right? We can categorize them, right? Having primary education, secondary education, higher secondary education, all those things can be categorized. So these are qualitative data. The other is a quantitative or numerical data which can be measured numerically. For example, height of an individual, right? We want to know the height of the individual. It gives in a particular number which we can compare whether the person is taller than the other person or not, right? So that is numerical data, right? How many kids you have, right? How many years of education you had, all these are numerical data. So qualitative data has two things, two parts in it. Nominal data, wherein it can be compared against, for example, sex, male and female. They cannot be compared and said that one is bigger than the other. Ordinal data, education, we can compare them. So we can say that primary education is lower than secondary education, college education is the higher, right? And quantitative or numerical data, we have discrete, for example, number of kids, or it can be continuous in decimals also it can come, right? So number of kids, you cannot have 2.5 kids, right? So in continuous, we can have few things like in decimals also it can go. In that continuous, we have an interval data and ratio data. We'll see a bit more. But interval data and ratio data is that this doesn't have a perfect zero. It doesn't have a true zero. Whereas ratio data has a true zero in it. So the types of variables, when we have variables, they are mutually exclusive categories. For example, coin toss, you can have a head or tail, right? If it has an head, then that table you cannot put a tail, right? It is either head or it is going to be tail. Then there is an order also, right? So if a person is poor in studies, he cannot be again marked as good in studies. It is mutually exclusive. Severity of illness, he can be poor, he can be moderate, or he can be good in illness. Severity of illness, right? Education level. Then types of variables, it can be a discrete also, whole numbers, number of vehicles, number of best friends. It can be continuous as decimals. For example, height, weight, all those things can be expressed in decimals. So in this, you have in interval data. So this one is for interval data. It can be obtained distance between two measurements, and the 0 point is arbitrary. For example, Celsius scale. This is the interval data, and ratio scale is where you have a zero. For example, if you use a Kelvin scale, then you have an absolute zero. Then it is a ratio scale. Whereas here it is an interval data when you use a Celsius scale. Ratio is same as interval, only thing is that it has an equal interval, equal ratio, and additionally it has a true 0 point. So these are the few examples in the category. You have about 6 patients we did, and the ages are like this. So it is continuous, right? And it can be the sex is male or female, it is nominal, and education primary, secondary, and all those things, it is ordinal, and the body temperature is interval. If the body temperature has been taken in Kelvin, then it will be a ratio. Different types of variables are different in their properties. Therefore, there are different statistical methods for different types of variables. For example, we have different tests for it. This mostly comes in the analytical part or the inferential statistics. But just for us to know, we use t-test for continuous data and chi-square test for nominal data, right? As well as we have all these things which we can know of as data. How about descriptive analysis? Descriptive statistics, you can say descriptive analysis, because we don't majorly do an analysis. We just present the data and see how what kind of pattern it has. So descriptive data can be for categorical variables or numerical variables. So the statistics can be the frequency. You can put it as frequency, how many persons are there in that particular category, right? Relative frequency or proportion of percentage, and cumulative relative frequency. We'll see one by one. And the chart, we can have a bar chart or the pie chart. So let's say that this is a data we have collected, right? We have examined about 600 participants, right? On the method of extraction, we found that 478 used was extracted using forceps only, 65 with elevators and forceps, and 57 required surgical removal, right? Then we see that about a little less than 80% have done forceps. So we know that forceps is the most popular method for removal of a tooth, right? Followed by forceps and elevator, and followed by surgical removal, right? So this is converted into percentage, and sometimes we convert into cumulative percentage, where this one 97.7 is for forceps only, and for both together it is 90.5, and all the three together it is 100%. Another example, 20 students were asked how many hours they worked per day. So they say that 5 hours I worked, 6 hours I worked, and their response in hours are given here. So this is how you put it. How many people work for 2 hours? It is 3. How many people work for 3? It is 5. Right? In this way, you can put it as frequency table. The another way is the relative frequency, right? How much of this, of the total is this, right? So we find that out of 20 students, 3 students work 2 hours. So it is 0.15 or 15 percentage. So like that, you can use it as relative frequency also. And then cumulative frequency, as I said, what is the value of 2 and 3? 2 hours and 3 hours students, how many students are there? This will mean as 0.40 of the total, or it is 40%. So this is again showing us percentage and cumulative percentage. Then the other way to present the data is using the chart, right? So here again, going back to the extraction case, forceps alone we have around 80%, a little less than 80% to almost 80%. Then forceps and elevator is 15%, and surgical LA is 8% only. Surgical GA is again 25. Or you can show it as the pie chart or graph, right? So you can show it as this is the majority, then you have the forceps and extraction, surgical LA, and surgical GA. So we can show it as descriptive statistics for categorical data as frequency, relative frequency, cumulative relative frequency, and chart for bar and pie chart. How to describe a numerical variable now? So categorical variable we already saw, right? It is mostly done as a frequency, proportion, or relative proportion, or cumulative proportion, or cumulative percentage, and then bars and charts, right? A pie chart and the bar chart you can use. How about the numerical? For example, height, how do you want to present it? So we usually use the measure of central tendency and a measure of dispersion. For example, there are 20 students whose height we have seen. We want to tell them the characteristics of the group based on height, right? So what we can do is we can take an average, but average might not be a bit accurate if many students are a bit different. For example, 3 students are very short and 7 students are very tall, and few students are average in height. So sometimes what you will get is, when you take an average, you will get that the height of the students who are very near the average, right? But that won't say about the smaller students, the shorter students, and the taller students. So what we do is we use a measure of dispersion of variability, right? It can be in standard deviation, it can be in variance. So that tells you how much variation it is there, right? For example, let's say that some students, so 20 students I've seen, and most of the students, or all of the students are between 160 and 180 centimeters only. So let's say that we get an average of 170. Then we go to another cohort of 20 students, right? In that, what we find is There are three students who are like 120 centimeters. Four students are 160 centimeters. The rest of the students are 185 centimeters, right? We might get an average about 175, right? But if we have a variation, that how much of it is there, then we'll know that most of the students are in the higher category, we can say. So that is the usefulness of the measured of dispersion. The other graphical method we use is the histogram and frequency polygon. So central tendency, as I said, it says tells the center value or representative value, dispersion of variability, how the data spread about the representative value and variation. So usual center tendency are mean when the group is a bit homogeneous, right? So we have a few smaller kids of smaller height. We have some medium height, some taller height. If it is almost homogeneous, then better to use mean, right? If it is not so, then median and mode are the better ways of doing it, and median is more popular. Dispersion, usually we go for the standard deviation if it is homogeneous. If it is not homogeneous, we go for the median and the interquartile range, and mode also we use the range. These are the formulas, but what we can do is you can use statistics to calculate all those things. All right, and this is the data for the normal data, where we find that there are almost every height is equally distributed, right? Then we have a normal curve. If we have a normal curve, then we'll know that the mean is here in the middle, right? And between 1 SD and 1 SD, we'll have 68% of the population falling into this height. Yes, here the mean weight was 60 kilograms. Mean plus 1 SD was the SD was 5 kilograms. So 55 to 65 kilogram of people would be 68% of the group. How about median? The 50th percentile of a set of measurement where it has half the value above and half the value below is called as a median. So how we do is we arrange them into alphabetical order or increasing order or ascending order. Then if n is odd number, median is the middle value, n is an even number, the median is the mean of the two middle observations. So here these are odd number of observations, so we can say 10 is the median. Here is even, so we take an average of 8 and 10. Interquartile range. The range between the 25th and the 75th percentile will be the interquartile range, right? So you arrange all the height in ascending order of the students. So let's say that we have 20 students here, all right? The first 25th percentage will be the first quartile, and the 50th percentage will be the second quartile, and 75th will be the third quartile. Mode, what is mode? The observation that occurs most frequently. The range is the difference between the largest and the smallest observation. So mode is the central tendency and the range is the dispersion, right? But not so accurate, but sometimes we might have to use mode and range. Right, this is a frequency polygon. Right, so the height of the bar represents frequency is your relative frequency, and then each piece of the bar is for each interval and numerical data. So normal distribution, we described it as a bell shape, right? So if it is a normal distribution, then the mean, median, and mode will be the same value, right? You'll find that the average we get is the most middle value, which is median, and also the most frequented value, because many persons are very close to that average or on that average. So to summarize, for qualitative or categorical data, we use table like frequency, relative frequency, cumulative frequency, bar or chart for par and pi. And central tendency, we have mean, median, mode. Mean is the most popular. Dispersion variation, we have range, variance, standard deviation, and interquartile range. And chart is histogram or box plot. Thank you.